This lesson, we're going to learn how to do multiplication of a vector by a scalar. Example 1, we're going to use the diagram on the right for the vectors a, b, c, d to compute the following resultants both geometrically and algebraically. Part A, we're going to find the resultant vector r, which is negative 2/3 of vector a. So we know vector A is a vector pointing 3 units to the right. That means if we switch the head and the tail, then it becomes negative A. And because we only want 2/3 of the negative A, that means the 3 units will times by 2/3 will become 2 units. So our resultant will be a red vector that is pointing to the left by 2 units. Part B, we want to find the resultant vector r, that is 2 times by vector b plus 3 times by vector c. So first, let's draw 2 times by vector b. So as you can see here, so this one is 1b and there's another 1b, so in total is 2b. Next, at the tip of the vector 2b, we're going to draw 3c, which means 3 times longer than 1c. So that's 1, that's another 1, that's another 1. So in total, 3c. Now we can find our resultant vector by connecting the tail of the vector 2b to the tip of the vector 3c. Part C, we want to find the resultant vector of negative 2d plus 2b. So we know positive d is pointing this direction. That means we have to switch the tip and the tail to get negative d. However, we know it's 2 times longer, so we're going to have negative 2d pointing this way. And at the tip of the negative 2d, we're going to add 2 times by vector b. So 1 times, 2 times. And from the very beginning tail to the very ending head, that's our resultant r. Now, we have to find those resultant vectors again, but this time we're going to do it algebraically. That means first, we have to find the algebraic vectors for vectors a, b, c, and d. In order to find the algebraic vectors, they have to be in position vectors. That means the tail is always at the origin, and we're going to define the coordinates for the head. So a will be 3, 0, vector b will be 2 and 3, vector c will be 0 and negative 2, and vector d will be negative 3 and 2. Part A, we are going to find negative 2 over 3 times by vector a. So we're going to do negative 2 over 3 times by 3 and negative 2 over 3 times by 0. So we're going to have negative 2 and 0. Likewise, for part B, we're going to do is 2 times by vector b plus 3 times by vector c. So we're going to have 4 and 6 and 0, negative 6. And how do we add the vectors? You do x plus x and you do y plus y. So our resultant will be 4, 0. Part C, we want to find negative 2 times by d plus 2 times by b. So once again, you do negative 2 times by negative 3, negative 2 times by 2, and 2 times by 2, and 2 times by 3. So you're going to get to half this. Now, how do I find the resultant? X plus x and y plus y. So our resultant will be 10, 2. Example 2, if vector x and vector y are 2 unit vectors, it means both vectors are having a magnitude of 1 with an angle of 30 degrees between them. That means the angle between the tails of the vector x and vector y is 30 degrees. We want to find the magnitude and the direction of the resultant of 3x minus 5y. First, let's draw a vector x on the horizontal line, and from the vector x, draw 30 degrees angle. Then we can draw a vector y and label them 30 degrees between them. Next, let's find our resultant, 3x minus 5y. So first, draw vector x 3 times longer, and at the tip of the vector x, we're going to draw a negative y, but it's going to be 5 times longer. So this is going to be negative 5y. And connecting the tail to the head to find our resultant. And now, since we know originally the angle between x and y is 30 degrees, that means this angle will also be 30 degrees because they are alternate angles. Since we know both vector x and vector y are unit vectors, that means 3 times by vector x is going to have a magnitude of 3, and negative 5 times by vector y is going to have a magnitude of 5. So now we have 3 sides, 1 angle. We can use cosine law to find the magnitude of the resultant vector. Since the angle that we know is 30 degrees, that means the magnitude of the resultant vector r will be isolated on the left-hand side of the equal sign of the cosine law. And after we compute it, we will say magnitude of the r squared equals to 34 minus 15 root 3. And we take the square root on both sides. The magnitude of the resultant is approximately 2.83. Now we have to find the direction of the resultant vector. Since the tail of the resultant vector is connecting to the tail of the vector x, so this is going to be the angle that we want to find. Let's call this theta. In a non-right angle triangle, there are 2 ways to find angle theta. One is to use sine law, and the other one is to use cosine law. And we know sine law cannot be used to find an obtuse angle. In this triangle that we have, this angle is an acute angle. That means theta could be obtuse angle. That means in this situation, sine law will not be safe to use, so we have to use cosine law to find angle theta. Since we want to find theta, then the side that is opposite to angle theta must be isolated on the left-hand side of the cosine law. So here is our cosine law. And we're going to isolate for cosine theta. So that's remove those 2 terms in the front, and then we're going to divide -2 and 3 and magnitude of the resultant vector r. So we're going to have cosine theta equals to approximately -0.4697. And we're going to take the inverse cosine. We're going to find theta is approximately 118.02 degrees. Therefore, we say the resultant is 3x minus 5y, which is approximately 2.83 as a magnitude, and the direction 118.02 degrees to vector x. Example 3. Using vectors, demonstrate that the 3 points A, B, and C are collinear. Co means together. Linear means straight line. Collinear means they lie on the same straight line. Collinear vectors, it means they are parallel. That means one vector can be written as a scalar multiple of another vector. On the other hand, that means non-collinear vectors are vectors that cannot be written as a scalar multiplication of one another. So for example 3, first, we're going to find vector AB, so which is OB minus OA. We're going to have -8 and 5. And next, we're going to find AC, which is OC minus OA. We're going to have 8 and -5. Since AB is negative AC, because you can see they are opposite vectors, therefore, AB and AC are collinear. This implies points A, B, and C, they are collinear as well. Now, let's use a diagram to demonstrate this. First, let's put the points A, B, and C on the Cartesian plane. Next, we're going to draw vector AB and vector AC. As you can see from the diagram, those 3 points, they do lie on the same straight line. And since I always use point A as the tail for both vectors AB and AC, that means I'm looking at point A as my new origin. So if I draw a new Cartesian plane with A as my origin, you can see point C will move to 8 and -5, which is our vector AC. And B will be at -8 and 5, which is our vector AB. And since AB and AC, they are opposite vectors, that means they are scalar multiplication of each other by -1. Therefore, vector AB and vector AC are collinear. That means points A, B, and C, they lie on the same straight line. That means collinear as well. Example 4, if points A and B are opposite vertices of parallelogram OAPB, and O is the origin. Find the coordinates of point P. First, let's draw a parallelogram. And at this point, we're going to label O as the origin. Since the name is OAPB, so from O, we're going to label either clockwise or counterclockwise OAPB. So we do OAPB. Next, we're going to put the coordinates on. So we know O is origin 0, 0, 0, A 1, negative 5, and 2. Since P we do not know, so we label X, Y, Z, and B negative 3, 4, 4. Using equal vectors, we'll be able to find point P. As we know, vector OA equals vector BP. So we know vector BP equals to OP minus OB. And isolate for the X, Y, Z, and we will get negative 2 and negative 1 and 6. So we know point P will be at negative 2, negative 1, and 6. Example 5. Given the magnitude of the vector x plus vector y is longer than both the magnitude of the vector x and the magnitude of the vector y, we know the angle between vector x and vector y is an acute angle. So, before we can determine the magnitude and the direction of the new vector 2x minus 3y, we have to find the angle between vector x and vector y. First, let's draw a diagram of vector x and y with alpha representing the angle between them. Second, we're moving vector y to the tip of the vector x to find the vector x plus y. Next, let's label all the sides and the angle that we know or we need to find. So we know the magnitude of the x is 8, magnitude of the y is 12, magnitude of the x plus y is 16, and that's label this angle theta. By using the cosine law and by isolating cosine theta, and then take the inverse of the cosine, we'll be able to find theta as approximately 104.48 degrees. Since we need to find alpha, and alpha and theta makes 180 degrees because they are supplementary angles, so we know alpha is approximately 75.52 degrees. Once we know the angle between vector x and y, then we can construct our new diagram to find our new resultant 2x minus 3y. So first, let's draw 2x, and we draw a negative 3y, and we can find our resultant r. Since we know the angle between x and y is alpha, then this angle will also be alpha because they are alternate angles. Before we can use the cosine law, we also need to know the side length. So we know the magnitude of the x is 8, so magnitude of the 2x will become 16. So the magnitude of the vector y is 12, so magnitude of the negative 3y will be 36. By substituting all the information that we know into the cosine law, then we will be able to find the magnitude of the r squared is 1264. Taking the square root on both sides and reduce the square root, we're going to get magnitude of the resultant is 4 square root of 79. Now we are ready to find the angle, the direction of the vector 2x minus 3y. So as you can see, the tail of the resultant vector is connecting to the tail of the vector x. So this is the angle that we want to find. Let's label them beta. Once again, since alpha is an acute angle, that means beta could be an obtuse angle. So we have to use cosine law to find beta. By using the cosine law again and isolate for cosine beta and take the cos inverse, then you will get beta is approximately 78.64 degrees. Therefore, we say the resultant, which is 2x minus 3y, equals to 4 square root of 79, which is the magnitude, with the direction 78.64 degrees to vector x.